which is also a man-made one. Then the third type is called as non-exact linear relationship. This is the normal situation or normal circumstance we come across this linear relationship. The fourth one is initially it's look like a non-linear, but by doing some transformation we can do the linear. And the last one is true non-linear relationship. So where we cannot do any transformation, without transformation we can simply show the non-linear relationship. Talking about in this particular course, we will talk about the regression model. When you have one x variable or explanatory variable, it is called as simple regression. If you have more than one explanatory variable, it is called as multiple regression. Then under each category, we have linear and non-linear nature, where in our course we are going to talk about only linear regression. Simple linear regression we went through. Nature of the relationship is linear. We have two variable, dependent variable and independent variable, or another term we call it as response variable and explanatory variable. The basic idea of regression is to predict the value of y for a given x. That is the main aim. So we have seen the model. So this is the concept of the straight line equation y equal mx plus c. Then the model that we have seen and some of the assumptions that we made. Right. Today we are going to start from this. Right. Give me a minute. I will. Can you all see the screen?
Yes.
Okay, right, fine. So I had some problem, technical problem. Okay, right. I'll start the lectures from this point onwards. All right. Hopefully, all of you can see. Once again, can you all see the slide?
Yes, sir.
Yes, sir.
Good, fine. So regression analysis. Further, when you talk about regression analysis, we have two variables. One is called as dependent variable. The other one is called as independent variable. Right. So we have two variables, dependent variable and independent variable. Right. That we have already seen. The dependent variable is y, independent variable is x. So when you have given a particular situation, you should be able to identify what is the dependent variable, what is the independent variable. So this is the basic model which we have already seen last day. So this is the observed value. These are the model parameters. These two are model parameters. All right. So this is a constant values, two constant values for a given data set. So this is the x variable, this is the error term. If time permits, we will talk about error terms at the end today. which refer as the simple linear regression. Which refer as a simple linear regression, right? We would interested to estimate the value of beta naught and beta 1. So that is first we want to identify. For a given situation, we want to identify these two these two values of beta naught and beta 1. So these are the most important one that we want to predict it at the first level. So how we are going to do it that? Right? So this is the equation, again, dependent and independent variable. Beta naught is the intercept, beta 1 is the slope, and the error. Error which is normally distributed on a random variable, which is a random variable, normally distributed, with the mean of 0 and variance of sigma square. So when you talk about the distribution of error, so this has to be with the value of mean 0 and the error variance sigma e square, right? So that is the assumption that we do, but we want to predict these two, beta naught and beta 1 value. So this is a diagram or the distribution given for the error value. So error value, as I spoke to you earlier, so the mean of the error value is 0, right? So it is showing, it should show a normal distribution. This is a condition for normal distribution. So you have negative value, you have positive value, right? So the error has to be distributed normally. Can you remember one of the assumptions that we have taken last week, right? As an example, look at this. Actually, the height has to come here and weight has to go there. Because just I have drawn it, doesn't matter. So because weight is depend on height, or height is depend on weight. Height is depend on weight, or weight is depend on height. Weight is depend on height, right? So that is why the height has to come on the x-axis. Height has to come on the x-axis. Weight has to come on y-axis, but it doesn't matter. This is an example. I want to focus more on this diagram. This diagram is called as scatter diagram or scatter plot, right? I have drawn the values of x and y value, right? Now look at, I am drawing a straight line which is representing all the data. This is the first line, this is the second line, this is the third line. So now, can you choose which line is the most appropriate for this given data? For a given set of data, which is the most appropriate line? Anyone? You'll have to answer now. Huh? Don't put it anything on the chat, because I'll have to walk to the computer and to the blackboard. You can answer, no problem. Which line is better? Blue, red, or green?
Red one.
Red one is better by looking at, right? Visually, you look at among these three lines. Red one try to represent more on this data, but I have drawn only these three lines. Now let me say how many lines I can draw representing all this. Is it only 3 lines? You see, I can draw another line like this. I can draw another line like this. I can straight line, huh? All are straight line. I can draw any number of lines as you want, right? So now I can draw another line. So all are straight line. So how many lines you can draw for a given data set? Any number. Maybe thousands or millions of lines you can draw. But what is more important is, which line you can draw, because I have drawn only 3 lines. If you draw hundreds of lines, you want to choose which line is the most appropriate. What is the technique that we are going to use to represent all the data? The technique that we are going to use is called as least square technique, to find out the most appropriate line. right? Least square technique is the one which we basically identify, which gives the best fit for the difference between the actual y value and the predicted y value. What do you mean by actual y value and predicted y value? Let's say this is the line that we are going to fit it. So how to fit this line, we will look at it later. So let's say this is my data as an example. So this data represent the value of x1 and y1, for example, x1 and y1. Now you see the difference between actual value. So this is the actual value. Y1 is the actual value, right? Actual value is the y1 in this example, and predicted value. What is this predicted value? Predicted value is the value that is we expect to be on the line. So that value. So minus, later we will give a name for this, y1 hat. Right? We will talk about this value. So y1 hat. So this difference is the one we are going to measure. So this difference has to be minimum as possible. So this is for one particular point. For the second point, plus we can say y1 minus y2 minus y2 hat, plus the third observation, and so on. It goes like this. So we want to find out the minimum value or minimum deviation between these two. So that is how it works. So you can see what is the problem here. Now if I take a value here, let's say this is x2, this is y2. So here the difference is minus, here the difference is plus. So when you add the minus and plus, they will cancel off. So that is the problem here. So that we are squaring it up, we are squaring it up, we are squaring it up. So that is the concept. So that is what we can say here. This is for the general term, summation. This is for the whole data. This is the observed value or the actual value, right? Actual value. I will erase it, then you can see. This is the right. This is the observed value. This is the predicted value. So there's a deviation is squared, right? So here the difference between actual value and the predicted value, right? It should be minimum as possible. So this value, the summation, has to be minimum as possible, right? The summation has to be minimum as possible. So this is what we call it as error term. So each and every observation, how much they are deviating from the main line, has to be reduced. So that is basically called as error term. So this is the observed value and this is the predicted value, whereas the difference should be minimum as much as possible. So this term is called as sums square of error. Sums square of error. This term is called as sums square of error. Right? So here the same example as I pointed out. Look at this. So this is the x1, this is the y1. So this is the observed value, right? So this is the observed value or the actual value. We can call it as observed or actual value, right? Observed or actual value. Now this is what we call as predicted value. So this is predicted value. So predicted value is on the line. Predicted value is on the line, right? So this is the predicted value for this y value, right? So likewise, we can write down the predicted value for all points, right? All points that is coming up with the x value, relative x value, and so on. let's say this x2, x3, and x4. So this deviation, as we said, it is the error term. So error term for first data, similarly error term for second data, error term for third data, and so on. So this error. So ultimately, in the least square technique, what we try to say is we try to minimize these error terms as much as possible. So that is what it says, right? So the error terms are there: E1, E2, E3, E4. So here we sum it up all the errors. Sum it up all the errors. Clear? Once you sum it up all the errors, then that is called as sums of square of error. So we want to reduce this sums of square error as much as possible. That is the objective of this technique, least square technique. This is the observation of second one, Y2. This is the Y2 observation. Y2 observation given by the beta naught. Beta naught is the intercept here. For a given data, it is constant. Then beta 1, it is the slope, right? So that is also constant for a given data. Then you have this x2 variable, x variable of the second observation, and respective error term. This error term may be positive or negative. So in this case, it is negative. In this case, it is positive. So that is why we want to square it up to get rid of this positiveness and negativeness. So the any points which is lying on the straight line as it is can be written as that, because no error term here, no any error term. Why? Because error term is 0. So that is why we are writing like this. So, right. So we write for a particular observation. This is the model, least square model. You don't need this formula, but you need, this is called as normal equation. Normal equation, right? So through normal equation, I don't know whether you have done in mathematics, this is called as partial differentiation. Through partial differentiation, we can come up with finally this. So this is where we want to predict the value of beta naught. So beta naught is depend on y bar minus beta 1 hat into x bar. Right? So we want to predict this. So this is an important equation, can't forget. So even in the examination, you need this information. We need to calculate the beta naught, so we need this information. Similarly, we can find out beta 1. So this is beta 1. This is another equation that you should remember. So this is normal equation. You don't need to remember this normal equation. This is how the differentiation or partial differentiation takes place. Don't worry about this. This is not necessary to learn it, but this is very, very important, that beta 1 hat is equal sum square of xy divided by sum square of xx. So this is important formula. So we'll have to have those two formulas to predict the equation. So that formula has been derived using the least square technique. So prediction equation is given as y hat. This is what we are going to predict. What do you mean by predict? If you have a line, straight line, for a given x, I can predict the value of y. So what is the value of y for a given x? Right? So this is what we call as prediction. To find out that, we of course need our beta naught and beta 1 value. Then you put the x value here, and you can get the y value. So this is what we call as prediction. We will see some example later. So first one is beta 1. Among these two models, first one is beta 1, which is giving the slope. That can be calculated as beta 1 equal sum square of xy, or in other terms, sum square of cross product divided by sum square of x. So sum square x can be expanded as such. So this is actually sum square of x. Sorry, sum square of xy. So that is sum square of xy. Similarly, we can expand the sum square of x. This is how we write the sum square of x. So this expansion you should remember, very important. All right. So this has been expanded as such. Then yeah. Yeah. Second one. Can you mute it? Second one, the intercept beta naught. You should remember this formula. Beta 1, beta naught hat is equal y bar minus beta 1 hat into x bar. So that you should remember. Right? These two formulas you should remember to find out beta 1 and beta naught hat. Right. Let's look at some of the computation. How to calculate. So I have x value, x1, x2, x3, and xn. Right? Somebody is making noise, disturbance. Can you mute it? Then we have y value, x value, and y value. Again, you have observations. It goes as a pair always. So when you add all these values of x, it is called as summation of x. Similarly, if you add all the y values, it is called as summation of y. Now you see, you square it. You square the x, that is called as x square. Add all the squares of x, that is called as summation.
Excuse me, sir.
Yeah. Yeah.
So we can't see. So we can't see that presentation for the video.
When
Some students are logged out.
yeah, you can't see me, all of you or only one?
Suddenly it was disconnected. Oh, now okay.
Huh?
Now okay.
Disconnected.
Yes.
Is it disconnected only for one or two or for all?
No, sir, for some students.
It can't be some students. Something wrong. Because disconnected means because from
All students are disconnected, sir.
Right. Now it is okay.
Now okay, sir.
Right. Okay. So you'll have to tell. Otherwise, I'll have to come to your place and see whether it is visible or not. So if you don't tell, I will keep on shouting. Right. So you can see here the variable x. You can calculate the variable x, right? Calculate the x, and then we can calculate the y value. Right? So if you add all the x values, it is summation of x. If you add all the y values, it is summation of y. If you add all the squares of x, the x1 square, x2 square, for example, if x2 is, let's say, x1 is 2, x2 is 4, this is 8, 9, 10, let's say. So here, what is the x square value? It is 4. Here the x2 square value is 16, likewise. So you add all these squares, then it is called as summation of x square. Similarly, you add all the y square values. then it is called as y square. For example, here 64, this is 100, and so in our example, right? So add all these values, so that will give that. Okay. The last one, the multiplication of this. That is summation of xy. Summation of xy. Right? So that is how the calculation goes. We have slope. What do you mean by slope? Slope beta 1. How we interpret beta 1? Right? Estimate y changes by beta 1. For example, each 1 unit of increase of x, how much increase in y will be given by beta 1. For example, if beta 1 is 1, if beta 1 is 1, what can you say? So when you increase x by 1 unit, y unit will be increasing by 1 unit. So that is what called as beta 1 equal 1. Suppose let's say beta 1 equal 5. When you increase x unit by 1, right, y unit will increase by 5. So y will increase by 5, huh? Not the value of y. Value of y depend on the beta naught as well. So value will increase by 5 units, right? Okay, right. So that is how we can interpret. So look at when beta 1 is equal to, that means when you increase 1 unit of x, when you increase 1 unit of x, it is y is expected to increase by 2 units. So that is called as beta 1 is equal. So what is beta naught? Beta naught is actually, it is the value of this beta naught. It is the value when x equals 0. It is the value when x equals 0, right? So average value of y when x equals 0. If beta naught is equal 4, suppose, that means it is the average value of y is expected to be 4 when x equals 0. Right? Looking at a typical example, number of studying hours versus months. Let's say x-axis number of studying hours weekly per week. Y-axis, it is the final marks. Can somebody tell me, by studying more and more, will you able to increase the marks or decrease the marks of your particular subject? Anyone? By studying more or allocating more hours for studying, whether will you be able to increase the marks or whether able to decrease the marks?
Both.
Both? How? How both?
More hours studying, more marks.
More studying will carry more marks, yeah. Yeah, that is true. But somebody said both. How they both කිව්වේ? ඉගෙන ගත්තොත් මාක්ස් ගන්න බෑ කියලා තමයි කියන්නේ. That means පරිචාල් මාක්ස් වල කියලා අහන්න meaning. Is there any saying like that? Somebody said both, that is why I am asking. No, if you see the number of hours per week a student spend on a particular subject. So these are on a particular subject. So that is increasing. You see, that is increasing. So when number of hours increases, the marks increases. Right? So that is an example. This is the predicted line. So we will see later on how to predict that. line. So we will see how to look at this predicted line, or to draw the predicted line. Anyhow, right? So here, what we can say is, when you increase the number of hours spending on that particular subject, it is increasing the marks, final marks, right? Now I have got this equation. Later we will see how to get this equation. So final marks depend on, this is your beta naught, right? This is your beta 1 hat. These are constant values. Depend on beta naught plus beta 1 into number of hours that you are studying. So how we can interpret beta naught and beta 1? Beta 1 is 3.17. Beta naught is 59.95. First we will interpret beta 1. Can somebody tell me what is beta 1? Can somebody tell me what is beta 1? Anyone? Don't put it in chat, because I cannot see the chat always, because I'm little away from the computer. So you can answer. Very difficult to wasting time looking at the chat. If you have any problem, just communicate. Yes, how we can interpret this beta 1? Anyone? Arosha?
Stop.
Huh? Arosha? Can you all see the screen?
Yes, sir, we can see.
Right. Yeah. What is the answer? What is the answer for my question? Beta 1 is equal to 3.17. You can tell in any language as you like.
Stop.
Slope, yes. Yeah, it is slope. It's good, but how you go and tell somebody who doesn't know slope? You have to interpret this. You have to interpret. Slope 3.17 කියලා කිව්වනම් මොනවද මේ slope කියලා හිතාව එක්කනේ. You will have to explain what it is.
Angle of that line.
No. Angle. Application. I'm talking about apply. Angle.
When x is changed from
What is
180,
what is hex here? Look at what is hex here. මේ වචනේ වලින් කියන්න.
when number of hours spent studying from 1 unit, how many?
Yes. If you study 1 hour, this is in hours, right? Number of hours. If you study 1 hour, right? If you study by 1 hour, you can increase your marks by 3.17. If you study 1 hour, you can increase the marks by 3.17. That is the answer. So don't say this is slope, this is angle, this is ඒව කියලා වැඩක් නැහැ. No one understand. කියන්න පුළුවන්, tell anybody, if you study 1 hour, you can get more marks. How much? 3.17 marks. Right? That is the explanation for beta 1. What is the explanation for beta naught? Anyone? Similarly. මේ වගේ කොහොමද explain කරන්නේ?
From the intercept.
Yeah, intercept. That is true. But now tell me in terms of studying hours and marks. Tell in that terms.
Unless you study, you can get this much of marks. The 0. Study hours 0.
Yeah. So yeah, you are partially right. When you don't study in the hostel, That means you are listening only lectures, right? So your knowledge is based only lectures. You are not putting any extra studies per week. So that what is the value of number of hours that you are studying extra? 0. If you study 0 hours of extra hours, still you can get 59.95 marks. That means 60 marks. You can get 60 marks even without study. That means you can get 60 marks even by attending the class without studying at home. Is it clear? So because the value, it is the value actually. It is the value 59.95. So that means without studying, you can get at least 60 marks on an average. So not for statistics, huh? Maybe some other subject. Not for statistics. Statistics we'll have to study. Clear? Anybody need explanation on this beta naught and beta 1 in this example? So we can predict the final marks based on this equation. As we said, the equation is already given there. Let's say an example, a person who is studying 12 hours per week, a person studying 12 hours per week of that particular subject. So the final marks of that is based on beta naught plus beta 1 into the number of hours. So that is 12. So that final answer is he or she can get almost 98 marks by studying hard, right? As an example, 12 hours per week. Similarly, if someone studying for 1 hour per week, still can get some marks like this. This for particular subject, not for my subject. Huh? Right. Right. We are going to do a small exercise. What this exercise says, the weight and the age have been measured from 6 people. Weight and the age has been measured from 6 people. Did you have the notes with you? Do you have notes with you? Did I send you a copy of notes? Did I send you a copy of the notes?
Yes, sir.
Right. Very difficult to get the answers. Huh? Right. So we are measuring from 6 personals. What is that? Age and the weight. Normally in the exam, we don't say age is X variable, right? So we'll have to identify this, which is the X variable, which is Y variable. What is X variable? X variable is an independent variable. Y variable is a dependent variable. So which is depend on which? Is age depend on weight or weight depend on age? Age depend on weight depend on age. Which is correct? Don't send it. Yeah, weight
depend on age.
Yes, weight depend on age, not the age depend on weight, right? So our X variable is age because age is the independent variable. Y variable is the weight. So we have 2 questions. One is we'll have to find out the regression equation, or in other term predicted equation. Both are same. The second question is you asked to find out the predicted weight for the age of 8.5 years. Right? This is not 5 years, 5 months, huh? Because the data is given as months. You see, here this is given in months. So 8.5 is a month. Huh? Doesn't matter. Only the unit is different. So here the serial numbers. These are the values for 6 people. So 7 months, the weight is 12 kilogram, 6 months, and so on. So those are the values. These are the weight. Then we'll have to do the summation. This is summation of X, right? summation. This is summation of x. This is summation of y. This is summation of xy. This is summation of x square. This is summation of y square. So you can fill all the tables as we did earlier, right? Already it is there. So we can calculate the x bar first, then y bar first. We need these values. Then go with beta 1 calculation. Simply we'll have to substitute all the values. From the previous table, we know all these values. Can you remember? So put all these values onto the table. You end up with beta 1 is equal 0.90. Beta naught we can calculate as y bar minus beta 1 into x bar. So that value is 4 point. So in other term, beta naught is 4.714. All right. Beta 1 is equal 0.9. Right. Now can you interpret this? X is in a month, y is in kg, kilogram. Can you interpret somebody? These two values. Can somebody interpret those two values?
Every 1 month increase in age for 0.92 kilogram birth weight will be attained.
Yeah, okay, that is good. Beta 1, when a child grows 1 unit, that means 1 month, the weight gain is 0.92 kilogram. Good. What is the beta naught? How we can explain beta naught? Practically? Anyone? How we can explain beta naught?
Usually the birth rate is 4.716.
Don't tell usually. You are right. You are right. Thing is, so what we said is this is 4.17, right? 4.17 at the 0 level of age. So what do you mean by 0 level of age? 0 level of age means the time of birth. So the time of birth, the average weight of the group that we have taken here, their average weight at the time of birth is 4.17 kilograms. That's all. Average birth weight for the group that we have taken is 4.17 kilogram. So good, fine. So this is how we interpret. So this is the predicted equation, as I said. Right. So that is the first question that I asked. The second question: what is the predicted weight at the age of 8.5 months, not years? So simply in the predicted equation, you substitute the value of age and get the value. So the predicted value at the age of 8.5 months, 12.54 kilograms. As an example, another one, what is the weight at the age of, let's say, 7.5 months? It is 11.62 kilograms. Right? So this is our example. This is our example. 6 points are there. This is called as scatter diagram. Scatter diagram or scatter plot. So this is called as scatter plot. Now we want to draw the line, predicted line. How to draw the line? How many points do we need to draw the line? We need 2 points. How to get these 2 points to draw the line? First point, we have already 0 and beta naught. That is 0 and 4.17. That is somewhere there. Right? The second point, is our X bar and Y bar. That is the second point, X bar and the Y bar. We know X bar is 6.83 and Y bar is 11. Then we can draw the line, predicted line. So that is how you write down the or draw the predicted line. Right? If somebody asks to predict the line, you can do it. So here we have another set of exercise. You can go through the exercise. So age, blood pressure, which is X and Y. So we know that age is the independent variable, blood pressure is the dependent variable. So it is X and Y. Normally in exam, we don't give which is X variable, which is Y variable. You have to identify their variables respective X and Y. Right? So by looking at blood pressure and age, it is obvious that age is independent, blood pressure is dependent. Right. So these are the values. So different X values, ages are there, ages. So it is continuing here. There are about 20 data. Then there are respective blood pressures. So you can do it as a homework. There are 3 questions. Find the regression equation. Draw the predicted line. And the third one, predict the value of the blood pressure at the age of 25 years. You can answer that. I'm not going to do that. I'm going to shift to the other topic. Any questions? Any questions? Can you all see the board?
Yes, sir.
Yes, sir.
Any questions? Fine. If you don't have any questions, we will go to correlation. Correlation is actually what I first introduced the term. We have predicted line on a scatter plot. This is one situation. Another situation. Like this. This is the situation 1. This is situation 2. Where you get more deviation of the observed value and the predicted value? Is it in 1 or 2?
In 1.
1 more deviation. So here you see, if you look at the deviation is within very wide bandwidth. Here the deviation is within a shorter bandwidth. So here we have high correlation, right? Here we have less correlation. So that is what I'm going to explain to you. The correlation is very high here compared to the second one. Sorry, compared to the first one. In second one, the correlation is very high. So basically, it is measuring the strength of the relationship. Strength of the relationship. It measures the strength of the relationship. Right? Okay. Now we are going to talk about all those very in detail. Finding the relationship between the 2 variables. Those are 2 quantitative variables. Why we are saying quantitative variables? There may be a qualitative variable. We can find out the relationship between those qualitative variables. So that is slightly different. That is a different type of calculation. So here we are going to talk about quantitative variable, measurable variable, right? Without being able to interfere the causal relationship. Correlation is a statistical technique used to determine the degrees to which 2 variables are related. So this is a scatter diagram I already mentioned. So in the scatter diagram, we have the coordinates x and the y coordinates. So you plot it. Both are quantitative variable. X and Y. And one variable is called as a dependent variable, Y, and the X variable is called as independent variable. You should not join the points. So this is totally wrong. If you join the points, that is totally wrong. And no any frequency table here. This is not a frequency table. Maybe sometimes for a given X value, there may be some other data points. So you can't simply add all these values and put it as a frequency table. So you have to plot it as a as it is, as the coordinates, right? Right. This is an example of a blood pressure and the weight. As you all know, weight is depend on blood pressure. Blood pressure is depend on weight, so that weight is a dependent variable. Blood pressure is a dependent variable and weight is an independent variable in this example, right? In this example, weight is an independent variable. Right. Now, if you look at this line, so let's say I have drawn a predicted line, it is already there, right? In the scatter plot, the pattern of the data, which will indicate how these relationships are. For example, here also we can find out the correlation. Here also we can find out the correlation. So here, when X increases, Y also increases in case 1. In case 2, when X increases, Y decreases. So here the positive relationship, here we call it as negative relationship. Positive and negative relationship, right? So we said positive relationship and also negative relationship, and there are cases no relationship. Look at here. So these are typical cases. So this is a situation, no relationship between X and Y. Look at again the same example, studying hours and the final marks. So this is a positive relationship, we could say. This is the second example, age in weeks and the height in centimeter, for example, right? Another one. So it is also positive relationship. Now look at for the negative relationship, age of a car. This is the brand new car at the time of you bought it. So after with that the age increases. That means 1 year after purchasing, 2 years after purchasing, 3 years after purchasing. The reliability is decreasing. Reliability is decreasing. So reliability means depreciation, right? When you purchase something, the depreciation is valid, added always. So the relationship is negative relationship. This is one. Now look at this example, pulse rate versus weight. I simply put, actually it should be other way around. So look at the diagram. So it is, there's no any pattern showing. It is scattered all around. So no relationship at all, right? So simple correlation coefficient. Why we call it as simple correlation coefficient is we are looking at the correlation only between two variables at a time. So this is one variable, this is another variable. We are looking at the relationship between only two variables at a time, right? There are other types of correlation like partial correlation. We don't study here in this course. So that is when you have several variables, more than two variables, right? So the person who found this correlation is called as Pearson. So it is called as Pearson correlation coefficient because there are other correlations also available, simple correlation, but it is for qualitative data. This is for quantitative data. Qualitative data, we call it as Spearman correlation. So that we are not going to study in this course. But here, Pearson correlation is correlation between two variables. Those are quantitative variables. Right. This is the actual definition for correlation coefficient. The correlation coefficient can be denoted as R. Correlation coefficient can be denoted as R. Right? So this R, correlation coefficient, can be defined as it is the strength of the relationship. So how strength the relationship is. I'm not going to give a break. I'm going to continue in another 15 minutes. I will stop. I have another appointment. Right. So this correlation coefficient value can range from -1 to +1. This value range from -1 to +1. So this R value range in between -1 to +1. Look at this example. So this has a positive correlation, right? This has a negative correlation. This has no correlation at all. This has a perfect correlation. This is called as perfect correlation because all the points are on the straight line. So this is called as perfect. This coefficient value, as I said, it can be -1 to +1, right? -1 to +1, right? But that means on a scale, so this is 0, this is -1, this is +1. If the value goes away from 0, if the value goes away from the 0, that means the strength is always better. Strength is always better. This sign does not mean anything other than whether it is a positive relationship or negative relationship. Look at this. This is one set of data. This is another set of data. As an example, here my R is 0.7. Here my R is 0.7. Here my R is, let's say, -0.7. So what can you say about this? This is a plus, huh? That is plus, this is minus. What can you say about this? When you talk about the strength is same because why? Both are having 0.7, the same value, but the direction is different. This is negative, this is positive. So the relationship is negative and positive, but the strength is same. So both are having same strength. So we can't say since it is a minus value, the strength is low. No. So the strength is same. We look at the absolute value, right? So it can have any value in between -1 and +1. So any value, if it comes closer to 0, that means the strength decreasing. The strength will decrease, right? So we will look at some of the examples, right? If the correlation coefficient is closer to -1, that means it is very good, but it is a negative, strong negative relationship. Similarly, if it goes closer to 0, that means the strength is very low, so we can say no correlation. If it is positive, as we said earlier, it is a direct correlation. If it is negative, it is indirect or inverse correlation, right? So if x increases, y decreases, or if y decreases, x increases, vice versa. In here, both are increases, right? When x increases, y also increases. So positive relationship is this one, negative is this one. The R can range from -1 to +1, we said already. So this R can be illustrated by a graph. Look at this value 0. If any value comes closer to 0, the strength goes down, right? If any value goes on the by the side, the strength increases. So we can say direct and indirect relationship. So this is a direct because it is a positive. This is a indirect relationship. If you have, normally we don't get a value except this man-made relationship. We can have -1 and +1. Those are called as perfect correlations, right? We can get either of these perfect correlation. That means, for example, if all the points are on the same line. So this is r equal -1. Here r is equal +1. Right? So normally we don't get this in natural condition. We don't get this information. Right? I mean, we don't get this r equal 1 and r equal -1, except in a case like man-made. Can you remember we talked about last time? Perfect relationship, perfect linear relationship, and so. Yeah, I will erase this. It's confused. So here, if it comes closer to 0, no relationship. Usually, this range we call it as weak relationship. Then this relation, I mean this area, we call as moderate relationship, right? Or intermediate relation, and the last one is called as strong relation. Okay, last one is called as the strong relationship. That means if any value in between 0.75 and 1, or -1 and -0.75, we call it as strong relationship. If it is 0, closer to 0, that means no relationship. If it is in between these two values, 0 and 0.25, then it is called as, even in minus case, right? 0 and -0.25, it is called as weak correlation. We call as intermediate or moderate correlation, and anything above or below above 0.75 or below -0.75, it is called as strong relationship. R is equal 1 if it is so, then we call it as perfect correlation. Look at this. This is a perfect correlation, but it is a -1. This is not a perfect correlation, but it has some minus value, 0.07. That is no correlation at all. We could say R is equal 0. Normally, when you calculate it, you never get practically a value R is equal. You make it R is equal 0.01, something like that, right? You don't get exactly 0. Then this is a perfect correlation, right? Where positive perfect correlation, so you have +1, and you see here where the strength is high. Here in this case or in this case, where the strength is high. What do you say? First one or second one? Where the strength is high. The bandwidth is high in second, isn't it? Bandwidth is small in first one. So which one is having more strength?
Second.
Because earlier I said if the points are very closer to, so this is one case. Take another case. This is another case. So where the strength is high? Here the strength is high. Why? Because all the values are closer to predicted line. Here the strength is low. All the values are away from the predicted line. So you see here most of the points are within closer to the predicted line. Here far away from the predicted line. Here the strength is low compared to here. But as I said, this don't worry about this minus and plus. Minus mean it is indicating coming down. Plus mean it is indicating going up. So the value you see here, the value, absolute value, look at the absolute value of this and this. This is much low compared to here. Last one in the graph, it is no correlation at all. So you can say R is equal to 0. That is also possible. So you see this width, look at the width. Whether it is positive or negative. So it has a very strong correlation. Look at the width here. So the width here is very high. So that it is, we could say it is a weak correlation. Right? Here we could say there is no correlation. There is no correlation. Here also the same story, no correlation at all, or no relationship at all. How we can calculate the values? So this is an important formula in calculating the R, or the correlation coefficient. So this is sum square of xy divided by square root of sum square of x into sum square of y. So this is our example. We have already calculated the values, right? X and y, y, then the cross product of x and y. So we have done all these calculations. So this is the expansion of that, right? As the sum square of xy divided by square root of sum square of x, sum square of. So actually this component is this sum square of x, this component, sum square of xy is this component. So that component, right? So this is the expansion of that. You should remember these formulas. So calculation of R. This is the shortcut to calculate the R. We will apply it in our example earlier, first example. So we need to have all these information: summation of x, summation of y, summation of xy, summation of x square, summation of y square. You need all this information from the previous example. The age in months, age in months, not years. Age in months, then age. Right. So if you calculate, simply you'll have to fill all the blanks. All the details are there. This is summation xy. This is summation x. This is summation y. This is n. So these are n, as you all know. This is summation x square. This is summation x. That 41 is summation x, right? So this is summation y square. This 66 is summation y. So it is already there in your table. You can. So our R value, which we can calculate, according to our guideline, we could say it has a strong positive correlation. Strong positive correlation, or strong positive or direct correlation. Right? So you can do the exercise for the second one also. Right, I will stop here. We will continue from next week. Any questions? Any questions? Any questions? So everybody understood perfectly, right?
Sir,
Yeah.
நோ கோரிலேஷன் இருக்குதானே?
விளங்கையில் எனக்கு கயக்கிற விளங்க எனக்கு விளங்கல.
நோ கோரிலேஷன் சொன்னீங்க தானே? வால்யூஸ்மா.
Yeah.
ஓகே சார்.
Yes.
நோ கோரிலேஷன் சொன்னீங்க தானே?
Yes. சொல்லுங்க.
அதுல சார் நீங்க சொன்னீங்க எக்ஸ் வேல்யூ கூடுது தானே, y தான் மாறாம இருக்கான எக்ஸ் வேல்யூ கூடுது தானே சார்?
விளங்கல நீங்க y வேல்யூ x வேல்யூ ரெண்டு பாப்போம். எஸ் என்ன சொல்றீங்க? கோரிலேஷன் y வேல்யூ x வேல்யூ once again சொல்லுங்க.
இல்ல நோ கோரிலேஷன் என்று சொன்னீங்க. அப்ப அதுல வந்து மாறாம இருக்கு, எக்ஸ் வேல்யூ வந்து கூடிட்டு இருக்கு, ஆனா y தான் மாறாம இருக்கு சொல்றேன்.
x வேல்யூ கூடிட்டு இருக்கு,
y மாறாம இருக்கு.
y மாறாம இருக்கு. Yeah, good. So you see that kind of see. Let's say this is the data as an example. So here if you try to develop a line, the line is something like that. So here this is we can call it as I'm talking about correlation, nothing else. So here r is equal 0. I mean closer to 0. We don't get the exact value 0. And exact value 0 உங்களுக்கு கிடைக்காது இந்த டேட்டாக்கும், but closer to 0, right? So when x increases, y doesn't have any changes. So this is called, I mean, no response. அதாவது இப்ப y equal mx plus c. Simple. விளங்குதா? y equal mx plus c. இதான் நேர்கோட்டு சமன்பாடு. Straight line equation. Okay? So this, hello, are you around? I need response. So this is
Yes sir.
right, beta 1. Can you just have a look? Same thing. I'm writing in a statistical form. This is mathematical formula. This is statistical formula. Same thing, right? So here m mean it is the slope. That is beta 1. What is the slope here? In the slope of slope is it's equal to 0. There is no slope, right? If the slope is equal to 0, this will become 0. This whole component becomes 0. So y is equal beta naught. So for this equation, y is equal beta naught in this case. So now it is not depend on x. So no relationship. Like that. X க்கும் y க்கும் இடையில சம்பந்தமே இல்லை. ஏன்னா இந்த y தங்கி இருக்கு டோட்டலா பீட்டா நாட். Is it clear? So that is why we call it as no relationship between x and y. The reason is because y is totally y is never depend on x. So we call it as no correlation. The slope is 0. Is it okay? Good.
Okay sir. Okay sir.
Anyone else would like to ask any questions? Anyone else would like to ask questions? We'll have to be hurry up. I need to go. That's why. Any questions? If there's any questions, I can answer.